Good morning and welcome to the Embedded Executive Podcast. My name is Rich Nass. I am with Embedded Computing Design. As you know, this week my guest is Frederick Napke. He is the co-founder and CTO of Spark Microsystems. How you doing, Frederick?
Great. Thank you for having me.
My pleasure. So we want to talk about a topic that I guess I'm a little embarrassed that I don't know that much about. Low Energy UWB or LE-UWB. Has this been around for a while?
Well, the company started this technology, I would say, a little over 7 years ago, but
Okay, let me
standardized.
interrupt you right there.
Yeah,
The
sure.
company started the technology, so this didn't come out of a standards group. This came out of a company.
Exactly. This came out of a startup company that was founded in 2016 and funded in 2018. So we had this idea. We brought this technology to be, and then we said, okay, while it's technology that comes from a company that's not standardized, will always be challenged to be truly ubiquitous. So then in 2019, we started the standardization effort, and now it's in the draft phase. And hopefully, if all goes well, we'll be officially in the standard. I'll give you the number if you're curious later this year.
And what standard body is this going through?
This is an IEEE standard, which is essentially in the 822.15.4. The exact number is 822.15.4 AB for the IEEE geeks listening. And it's essentially an extension of the ultra-wideband standard that's being used right now in AirTags or car keys, except our technology is very different. And I guess I'll expose that to you today a little bit.
Go ahead and expose. What's the difference?
Yeah, so essentially the only thing that our technology, low energy ultra-wideband, has in common with the classical ultra-wideband stuff used in AirTags and car keys is the spectrum. We use the same license-free spectrum. Worldwide, there's bands that are allotted to that spectrum. So that's great because you don't need to license it. As long as you're within the regulatory limits, you can use it. So that's great because Bluetooth, of course, in 2.4 does the same thing, and Wi-Fi,
Mhm.
it's great. You have these wireless chips that can come and not have to pay for the spectrum. So we use the same spectrum as they do, except our technology is tailored to data communications with, I would say, four key value adds, and then I'll stop because I could go quite a while on those four. So first, very low latency data transport. We're talking about 100 microsecond latency end to end. Very high throughput for a low power. Yes, go ahead,
Okay, hold on.
Rich. Yeah,
So let's go through each of these. When you say
yeah.
very low latency, compare that to the other technologies, so we can put it in its place.
Yeah, well, look, if we take a Bluetooth low energy radio and we really squeeze it down, you could get latencies on the order probably of 10 milliseconds. In audio, though, we're talking about typically 50, 100 milliseconds, right? That's Bluetooth low energy. It's pretty good, no question.
Mhm.
In our case, low latency in audio means 3 milliseconds. Low latency in data is, as I said, 100 microseconds.
Okay.
So I would say it's an order of magnitude lower latency than, say, BLE if we wanted a really quick comparison here.
Okay. Sorry, I keep interrupting you, but okay, what was number
Sure.
two?
Number two is relatively high data rate of 41 megabit per second physical data rate, which is compared to Bluetooth. Bluetooth typically is a 2 megabit per second PHY rate. So that's, again, an order of magnitude higher than Bluetooth. And what's very
But do you
important,
need that for the applications that, I'm sorry, do you need
yeah, go
that
ahead.
for the applications that you are destined for?
Well, that's where we see customers come to us. They often have an ensemble of things they come at us with. Sometimes it's just because they want low latency. Sometimes it's because they want low latency and high throughput. And sometimes, if we're lucky, it's all four, which I'll fully expose. So I would say it depends on the customer. The good thing is, though, every one of those unique capabilities of the technology can find its own place in the market. I think we're strongest, of course, when a customer comes and says, well, I actually need 3 out of 4 or even 4 out of
Mhm.
4 from your technology. And then, of course,
Right.
we're much harder to displace because they get a lot for the technology in their use cases, right?
All right, let's see if we can get through all four without me interrupting you again.
Sure. So very high throughput, as I mentioned. Then we can do all this, and that's critical. Otherwise, I don't think it'd be that exciting, is we can do it at ultra low power. meaning that our efficiency per bit transmitted and received is about an order of magnitude better than Bluetooth Low Energy. Hence why we called our technology Low Energy ultra-wideband.
An
Very
order of
energy
magnitude
efficient.
better than Bluetooth Low Energy?
Yes, that's right. Yeah.
Okay, this is where the
Skeptics will,
skepticism just kicked
sure,
in.
sure.
What's the number that you're talking about?
So if we usually efficiency is in nanojoule per bit, so our technology is between 1 and 2 nanojoule per bit, whereas I would say the best Bluetooth Low Energy implementations out there are probably on the order of 10 to 15 nanojoule per bit. So, order of magnitude better. And, it's not magic, and I understand skeptics would be like, wait a minute, how do you do that? The radio, and we could go into details later, is really changing the way we transmit and receive RF signals. It's really changing the waveform that we're using to communicate. And that allows us to do a lot of particular things to the architecture to get to what I just said. It's not just I took a radio, squeezed it down, right? There was architectural changes we can get into in a bit. And then the fourth one, excuse me, is the resilience to interference. The ultra-wideband spectrum is about 3 gigahertz wide. That's a lot of bandwidth to work with. We're not using it to do pure data rate, because obviously in 3 gigahertz of bandwidth, you could brute force this into being a gigabit per second radio. That's not what we're doing. We're using that spectrum to be very robust to interference, whether it be 2.4 or 5 gig, 6 gig interference, cellular interference, and that's the other fourth leg, right? So the fourth leg is low latency, high throughput, very energy efficient, and finally robust to interference, high robustness to interference. So these four things kind of are what embodies the value proposition of this technology that we call low energy ultra wideband.
I should have asked you this at the start, and I
Sure.
apologize. Are you guys producing semiconductors, or are you licensing IP, or both?
So our company sells chips. So we sell
Okay.
transceivers, and we have now 2 generations shipping. Our first generation that started shipping a few years ago, and the latest second generation that started shipping last year in 2025. So we're a chip company. We're not an IP house. Obviously, when you talk to the big fish strategic partners, they may want to do licensing, but that would be, it's not a business model of our company. It would be more done as a strategic play if we wanted to license the technology.
And it's a standalone transceiver. You wouldn't be embedded with an MCU or something like that.
Currently, the product line is a transceiver alone with all of the baseband, of course, the digital modem, all the stuff. So you do need to bring a host processor to the table, which we find is great for customers because most of them come to us already with their processor on their systems, and they basically enhance or augment their systems with our transceiver, and they don't have to pay an extra ARM license, or the price of it. So it makes us quite cost competitive. We can be very competitive on cost when needed for consumer electronics, but also it comes with a lot of, I would say, customizable design, because then the host processor can be, I would say, mutually agreed upon with our customers. Of course, in our future, like any wireless company, I'm sure we'll offer system on chip in the coming years. But for now, we are a transceiver-only chip company.
So I'm always playing devil's advocate with you. So is the downside to this, and maybe downside is the wrong word, but when you do Bluetooth or even Wi-Fi, you have compatibility with the whole world. UWB does not necessarily have that same compatibility. Is that what people would say is the trade-off here?
Yeah, low energy ultra wideband has for a problem that it's not ubiquitous yet. So whether we like it or not, any novelty in the world was never standard. Otherwise, it wouldn't be a novelty. So we have this rite of passage where now we're in the phase where this technology is being adopted by a good amount of customers, and we hope to continue expanding. But for sure, if you use Bluetooth, you can find an endpoint pretty much anywhere, right, today, and that's a great strength of Bluetooth. And by the way, Bluetooth is doing great. We're not trying to replace Bluetooth per se here. I think we can augment it and complement it where the use cases don't make sense for Bluetooth, right? But yeah, you hit the nail, right? The fact that it's not ubiquitous technology is, of course, always more difficult. So the customer has to control the endpoints, right? They have to be in control of the endpoints, which often in a lot of use cases, actually, it's not so bad. But in use cases where, for example, you need connectivity to a smartphone, that of course makes us more challenged to penetrate those kind of use cases, right? Because we're not into smartphones.
Now, the other one, which is probably even bigger, is the lack of a second source. Is there anybody else doing this?
That's true. We are the only company that produces these chipsets today. However, as I just mentioned to you, the technology is going to be part of the IEEE standard this year. It's already, by the way, published in draft format if somebody really wants to go and have an early start. So yeah, however, we do fab our chipsets in Taiwan with some of the biggest out there that are often considered as multi-source because they have more than one fab and
Mhm.
so on running the process flow we're on. So yes, it is definitely I would say, quote unquote, a risk to go with a single source provider. But again, novel technology rarely had dual source from day one. And that is kind of a feature of being a novel technology. We do hope, though, thanks to the standard, thanks to the fact that hopefully as customers adopt the technology, some strategics might come and want perhaps to license the technology and offer second sourcing. But we're not quite there yet in the history of the company, right?
Okay. I always hear UWB in the key fobs.
Yeah.
And this sounds like it would be a perfect spot for that. What are the other places that you're seeing potential use?
Well, most ultra-wideband today focuses on time of flight ranging and
Hmm.
is great for key fobs and air tags and great use case. And it's the first time a wireless radio is integrated into a smartphone in 20 plus years after Wi-Fi and Bluetooth, right? So that's not a small feat that ultra-wideband, classical ultra-wideband has done. Where Spark comes in with low energy ultra-wideband is really to say, well, ranging is great, but there's more than that ultra-wideband can do. And I just mentioned those four vectors of value, right? So
Hmm.
what if I have a wearable device that needs to stream video or audio continuously to a user? Bluetooth just can't do video, and Wi-Fi will just
Hmm.
drain the battery if it has to continuously stream data. So the use cases of, I would say, the AI world, whether we like it or not, it's happening where people will want wearable devices that can have rich information streamed to the AI in the cloud, so it can be smart and have context,
Hmm.
and stream data back to the user in a different form than ChatGPT today, which is a keyboard interface, right? And we all understand that physical AI, and that's a buzzword that's been that's been thrown around in the last few months or years, is
Hmm.
key, is for users to really want to use this. It can't just be driven by your keyboard and monitor, right? It's gotta have an interface, or even having your smartphone in your face and walking in the street talking to it. I mean, that's fine maybe for some people, but obviously most people who want it embedded in their life in a more elegant fashion, and that at least the world seems to think is gonna happen with these next gen wearables. And I'll stop with that thought. Those next gen wearables, yes, they'll need AI, but the AI won't be able to run on those wearables for compute reasons, right? ChatGPT is not running anytime soon on a pair of glasses locally. It's going to have to go to the cloud. And if you need to go to the cloud, you need low latency, high throughput, everything I just mentioned, right? At low power. So we think the technology at least can enable that. Okay, so the next gen wearables. And I would say in more palatable terms of markets that exist today, and I'll conclude with that, people need us in very high performance peripherals like gaming mice, gaming headsets,
Hmm.
gaming keyboards, where the gamers want really wired. They want a wire, but they don't want the wire. You know what I mean? And the
Yep.
ultra wideband, low energy ultra wideband can give them that wire-like experience, even though it's wireless.
And where are you today with respect to shipping stuff? Do you have silicon now?
Yeah, so as I was saying, we do have two generations of silicon shipping. We're deployed in several customers' product. Unfortunately, not all of them are public, but we have, several public announcements. We have gaming mice companies in Japan and in China that have released gaming mice. We've got some very high-end hi-fi speaker companies that use us to connect the left speaker to the right speaker because we all know audiophiles will not do lossless or compressed audio. They really want pristine audio source, and our technology is able to provide them that at low latency. So we've had these inroads. We also have a lot of projects that are not yet public in industrial IoT, where customer uses to transmit data to robots at very low latency and very high robustness. Obviously, in industrial environments, interference is really challenging. So we've had that. And we also have customers using us to make ultra low power tags to detect presence and send sensor data at quite a high polling rate. And the beauty when you're low power is you can have a high polling rate without killing the battery. So it really create these tags that are very responsive. So a lot of, I would say, use cases that are extension of today's use cases, but also some that are completely novel because no wireless technology could do what we can do today.
Okay, so to conclude, I have to ask this final question. Are you being set up to be acquired?
I would say the founder group, I'm one of the founders. Our goal is to build a sustainable, profitable company. We are not naive, though. We understand that wireless companies that succeed often are acquired. Like any company with a board, we're not, against that, but we are not building a company to be acquired. We're building a company to bring a new technology to the world and ideally attack as many customers as we can so that the technology becomes standard. Because I think this is where our impact as a company will be biggest. Once this company is standard and everybody can access an endpoint with this technology, wireless use cases for everyone will be very different than they are today, right? As Wi-Fi, Bluetooth. It's been 25 years, incremental improvement. We need something. Obviously, I'm biased when I say this to you, right? We need something to kind of have an inflection in wireless capability for your personal area network. And it's been fairly standstill for the last 20 years, right? So we hope to be that technology.
That's awesome. Well, I appreciate your time, Frederick. This is very enlightening for me, for sure, and I would guess for the audience as well.
Well, thank you, Rich. I do appreciate it. And if anybody got their interest piqued, they can come to sparkmicro.com and check us out. There's a lot of data there for them to get more info on the tech.
Awesome. That was Frederick Knapke. He is the co-founder and CTO of Spark Microsystems, and I am Rich Nass with Embedded Computing Design.